definition of sensitivity, it is that amplitude of AM signal which when we apply to the receiver will generate the output power of 50 milliwatts. So let's say for example, when the input is 10 millivolts, if the AM amplitude is 10 millivolts and if the power generated is 60 milliwatts, next we reduce the amplitude to 8 millivolts, the power generated is 50 milliwatts, and if I apply 6 millivolts and the power generated is, let's say, 40 milliwatts, we conclude that the sensitivity of the receiver is 8 millivolts. This simply means that any AM signal that will be received by the receiver must have at least 8 millivolts of the amplitude. Only then it will generate the power of 50 milliwatts, and that power will be sufficient to generate the final output signal. Any amplitude greater than 8 millivolts will very much generate the final output without any problems, but any amplitude less than 8 millivolts will not generate the enough AF power to be detected or to be represented in the form of final output signal. And hence we conclude that any receiver, if it has to have better sensitivity, it should be able to detect signals with lower amplitudes, or it should be able to generate the power of 50 milliwatts even for lower signal amplitudes. Receiver sensitivity is also called receiver threshold for a simple reason that that's the threshold amplitude which should be present on the input side. Any input signal less than threshold amplitude will not be detected by the receiver. Like we had discussed for selectivity, the receiver sensitivity also depends upon few things. It depends upon noise power present at the input of the receiver. If the noise present on the input of the receiver is very large, in that case, even with the large signal amplitude, the detection may not be possible. In such a case, receiver sensitivity will be very poor. So one way to improve receiver sensitivity is by reducing noise at the input of the receiver. Second is receiver's noise figure. Receiver's noise figure is nothing but the amount of noise which is being added by the receiver. If the receiver is adding a lot of noise to the signal, even in that case the detection and the generation of final output signal may not be possible even with good enough input signal amplitude. In such a case, the sensitivity amplitude must be increased so that we can overcome that internally generated noise and can produce the output signal. Noise figure of the receiver can be improved by using noiseless amplifiers. There are amplifiers which do not add large noise, or they add noise as good as zero to the incoming signals which are to be amplified. Such noiseless amplifiers will improve the noise figure of the receiver and hence also the sensitivity. Sensitivity also depends upon selectivity of the AM detector. If the selectivity of the detector is very good, that means its ability to reject unwanted frequencies and only the desired frequencies. If it is good, then sensitivity will automatically improve. It depends upon bandwidth improvement factor and gain of IF and RF amplifiers. So after noise figure, it depends upon selectivity, it depends upon bandwidth improvement factor, and it depends upon gain of RF and IF section. If the gain of this section is very large, then even very small or weak amplitude signal will be amplified, and before it goes to the AM detector, it will be of very good strength or amplitude, and hence demodulation will not be a problem. So if you can improve all these factors, then overall sensitivity of receiver can be improved.